Okay, so here we are, 7.4. As we talked about in the last video, this is adding, subtracting, but this is with uncommon or unlike denominators, and that is our only objective. So that's adding rationals with unlike denominators. And so this is what we were talking about. This I've copied over from the last lecture. This is just our little procedure for finding the least common denominator. And so when you're adding or subtracting rational expressions unlike the denominators, the first thing we do, step one, is find that LCD. The second thing we do is rewrite all the fractions as equivalent fractions. And then we add or subtract like we did in 7.3. Because now we have common denominators. So these first three examples, these are the three problems we started or ended the section with last time. So 3n plus 1 over 2n plus 2n minus 4 over 3n squared times 2n minus 1. So we found that the LCD last time for this was 6n squared times 2n minus 1. We wrote equivalent fractions that stated our fractions were 3n plus 1 times 3n times 2n minus 1 all over 6n squared times 2n minus 1, so this is number 1, plus our other fraction was 4n minus 8 over 6n squared times 2n minus 1. So that was our final result of the last section. So now we have to simplify and add. So the first thing I do is just simplify everything on top and then add it together. So distributing all this, we get 18n cubed minus 9n squared plus 6n squared minus 3n plus the 4n minus 8, and I can write this all over 6n squared times 3n minus 1. And then when we simplify, this simplifies down to 18n cubed minus 3n squared plus n minus 8 over 6n squared over times 3n minus 1. 2n, sorry. And I am going a little fast here only because this is just simplification to go from here to the final answer. So just adding up and subtracting the like terms. We should have a good amount of practice of that at this point. Number 2, our LCD was negative 3 times x minus 1 quantity squared. And our equivalent fractions that we found was x cubed minus 1 over negative 3 times x minus 1 squared, and this was up here was times x minus 1, forgot that, plus, or minus negative 45x squared over negative 3 times x minus 1 squared. And again, all there is left to do here is simplify the top, FOIL it out, and then this minus minus becomes plus a positive. Notice our denominator is going to stay negative so that we can just add across the top. And so we end up with x to the 4th minus x cubed minus x plus 1 plus 45x squared over negative 3 times x minus 1 squared. Now the only thing we could do here is rewrite this in order, and because I'm running out of space on this page, I'm not going to. And there's no reason other than we like to write things in order for degree purposes and factoring purposes to move that over. But that is our final answer for number 2. Number 3, our LCD that we found from the last section was negative x minus 3 times x squared, x to the fourth minus 9. And we found our equivalent fractions, all three of them. So the first one was x squared plus 3 times the quantity x to the fourth minus 9 over negative x minus 3 times x to the fourth minus 9 plus negative x plus 3 times x minus 3 over negative x minus 3 times x to the fourth minus 9. And then finally minus negative 3 times x minus 3 times x squared minus 3 all over negative 3 times x minus 3 times x to the fourth minus 9. Again, this minus is going to make both of these positive. Since this is all multiplication, we only distribute the one negative. And then all that's left is to simplify, FOIL, FOIL, FOIL. And when we do that, we get x to the sixth minus 9x squared plus 3x to the fourth minus 27 minus x squared plus 9 plus 3x cubed minus 9x squared minus 9x plus 27, and all of this is over our denominator, this thing. I'm running out of space here. And when we simplify our numerator, we get x to the sixth plus 3x to the fourth plus 3x cubed minus 19x squared minus 9x plus 9. And this is all over our denominator, negative 3 times x minus 3 times x to the fourth minus 9. I'll put some brackets here, and that's the final answer. And again, I'm moving fast here because this is just some simplification, and at this point we should have some good practice, but you can verify that I've done that correct by simplifying on your own, foiling these out, making sure I've added up everything correctly. On the back side, we're going to do two more. We're going to work these through from start to finish. So those last three we can go fast because we did most of the work in the last section. So we're going to start with number 1 here, and the first thing we're going to do is we're actually going to factor, the denominators are already factored here, we're going to factor the numerators too, because it may help us in the long run. So x squared minus 25 is x plus 5 times x minus 5. And this is over x plus 5 quantity squared plus 3 times x plus 5 over 4x minus x minus 5 times x plus 2 all over 10. So the reason we're factoring the numerators is 1, it will help us when we have to simplify, and 2, notice we can cancel one of the x plus 5s over here. So we're actually not going to worry about 2x plus 5s, and our LCD becomes a little bit simpler. It needs the 4, it needs the 10, it needs the x, so this is 2 squared, this is 2 times 5, so it needs 2 squared x times x plus 5. 2 squared times 5 times x, because it needs this 5, it needs both of these 2's, it needs this x, and it needs this x plus 5. So that means altogether we have 20x times x plus 5. And so that means that now we look at what's missing. So from the first one, it's 20x. So I'm going to stick a 20x on the top and on the bottom. Here, what's missing is the 5x plus 5. So this is 3 times x plus 5 times 5 times x plus 5 over 20x times x plus 5. And then what's missing here is 2x, x plus 5. So this is x minus 5 times x plus 2 times 2 times x plus 5, x times x plus 5. All over 20x times x plus 5. And so now we're just going to distribute. So we have 20x squared minus 100x plus, this is 15 times x plus 5 squared, which is x squared plus 10x plus 25. And then this is minus x minus 5 times x plus 5 is x squared minus 25 times x plus 2 times 2x. And this is all over 20x times x plus 5. So now we can distribute and FOIL this last term here. So we have 20x squared minus 100x plus 15x squared plus 150x plus 375 minus, we'll put the 2x here and we'll FOIL these. We get x cubed plus 25, or I'm sorry, plus 2x squared minus 25x minus 50. And this will be all over 20x times x plus 5. One more distribution to do here. So we have 20x squared minus 100x plus 15x squared plus 150x plus 375 minus 2x to the fourth minus 4x cubed plus 50x squared plus 100x all over 20x times x plus 5. So now all that's left is to collect like terms. And when all is said and done, we end up with a negative 2x to the fourth minus 4x cubed plus 85x squared plus 150x plus 375 all over 20x times x plus 5. So this was a long one, but this is because we had to go through all the steps, and I was deliberately not simplifying. So number 2 here, notice that again we can cancel if we factor this to x minus 3. It would be x plus 3 over x minus 3. And our LCD then would be 5x times x minus 3. So that means here all we're missing is 5x. So it would be 5x times x plus 3. And this would be over 5x times x minus 3. And then it's minus, all we're missing is the x minus 3 here. So this is 2x minus 6 times x minus 3 over 5x times x minus 3. Here we're missing the x minus 3 and the 5. So we would need plus, if we look at this, this cannot be factored, x squared plus 7x minus 12 times that 5x distributing to make my life a little bit easier, minus 15 over 5x times x minus 3. So all I did was, since we're missing 5 and x minus 3 from this third term, multiply top and bottom, and I distributed the 5 to that x minus 3 so I could FOIL this out all at once. Now I am going to let you try this out, get some practice, some more practice doing your FOILing and simplifying, but I will tell you your final answer should be 5x cubed plus 23x squared minus 138x plus 162. And this is all over that denominator of 5x times x minus 3. And that is the end of 7.4 for us. So some challenging problems. Did you get some good practice in the homework? Again, if you're having issues, make sure you come see me in office hours and we'll work through them.